Okay. It's Monday. We are back on the LumenPnP build. Welcome to the IQ Workshop, a place where I try to get smarter. And tonight we are working on a pretty ambitious electronics project to build a LumenPnP machine. To date, we have done some work to the LumenPnP in that we have built the core frame. We will get and have a look at that in a minute, but just wanted to do a quick overview as to what I'm going to be working on tonight specifically. So let me just go over to the PC, and here you can see the LumenPnP machine, and this is the machine that we're looking at building. It is, I'm trying to figure out how to navigate this. Why, there we go. So we are building this machine. This frame has been completed. All of the core components have been 3D printed. And we're getting into finalizing the linear motion system. Let me just strip back this machine in CAD so you can see what we're going to be working on tonight. So let's disable a few bits and pieces. We're currently working on the open source package from GitHub. So if you want to have a look at this machine yourselves, if you have a look at, if you're watching on YouTube, you take a look at the description, there will be a link to the GitHub page for the Opulo's LumenPnP machine. See Waffles, welcome into stream. How are you doing? Buck Naked, welcome, welcome, welcome. So let me just strip things back. I gotta tune my brain. I've been jumping backwards and forwards from CAD programs, and they don't share the same navigation functionality. So my brain is a little bit frazzled, just a little bit. So let's get rid of some of these items. How you doing? How you doing, C Waffles? Hope you're doing good. Just get rid of these feeder rails. Oh, we don't want to do that. We want the feeder rails, but we don't want the items on the feeder rails, do we? Okay. Is this what we want to get rid of? There we go. Let's get rid of the rear set. And this assembly here, we're probably not going to do anything with too much tonight, but we will see. I see what you're doing there, guys. So first and foremost, I'd like to offer up an apology from my last live stream. I had a bit of an issue with my YouTube live chat, but now I believe I've got it all sorted. So fingers crossed, fingers crossed. If anybody in Twitch can see YouTube chat messages that I'm missing, can you please let me know? And as I say, we're live streaming on Twitch and YouTube tonight. That seems to be my forte at the moment. We're doing a lot of lives for the YouTube guys. We're doing a lot of live streams, and I've got some videos that are coming up soon. But yeah, there's a lot of work to be done. A lot of work to be done. Exciting times. Right, so this is the motion system that we are currently working on. Right now, we have done everything with the exception of installing the linear rails, because we weren't in possession of them. We were waiting them to come through the post. And that's what we're going to be doing tonight. We're going to be installing these linear rails, and we're going to be fitting the belts. We don't have staging. We don't have a motherboard, so we're not going to be able to get the machine moving under its own power, but we should be able to hand operate the machine to slide things around, make sure we're square, etc. So if I go to my overhead camera, I can actually switch off this camera, and we can jump over to this camera. So there we go. There's the live view of the Lumen. It's slightly delayed. There is a little bit of a delay in this screen. So apologies for that. I was unable to tune out the delay before stream, but we'll work it. We'll work it. And we will we'll make a start. I've done a bit of knolling. I've got some components over on the other side of the bench. So let's get things going, right? Oh yes, yes, Buck. I did. I've actually made a small extension. I've got some lumber, and I got it put it through my planer to get that down to thickness. We are good to go in that regard. So let's have a look at these linear bearings. So they all came to one size. It's going to be a bit weird because you're going to see me moving in that camera, and then I'm already at my desk. All right. So I've got these linear bearings. These are effectively making up the motion system of the machine. Now, these were originally all the same size. They were 550 millimeters, if I'm not mistaken. But this one is 525. So I actually had to cut. Which one did I cut? This one. I actually had to cut this one. Remove 25 millimeters off the end of this item, right, off this bearing. So I guess it remains for me to find out what screws I need, and we can just populate some T-nuts and bolts on each of these bearings. And then what's going to happen is that they are going to get installed along this linear rail just here, right? That's so weird. Okay, so to stop confusing things, I've turned the face cam off, so that's to be expected. We're going to put this cut one away for a moment because we need to put the X-axis rail together, and that's yet to be done. So let's prep this. In fact, let's turn the face cam on studio mode. There we go. So we'll work like this for the moment. That's kind of funny. That is kind of funny. Right, okay, so let's get these bearings out of their packaging. These haven't even been opened as yet. So for those of you who don't know, these are linear bearings, and they have a very special bearing race. So if you've used 3D printers at all, you'll see that there's been like there's V wheels that are installed, and they run across a V channel, right? You get this 2020 extrusion, and you get a V wheel installed here, and it grips it and it slides backward and forward. The wheels are on a round bearing race. Well, these bearing races are actually flat, and these are, if I flip this over, you can see the bearings inside the bearing race, and if I slide this backwards and forwards, the bearings like grip the rail, and they recycle, they go all the way around. And it's really important that you are careful. You'll notice there's a little bumper just by here and here on either end, and that's to prevent this bearing from coming off the rail. And the reason for that is that if this comes off the rail, all of these ball bearings just go everywhere. About us, welcome in. How are you doing? I hope you're well. So let's quickly jump over to the PC. Let's jump over to the PC. And let's have a look at how these... Buck, thank you so much for the cheers. Appreciate you, buddy. How's your evening going, about us? Slingshot Life, welcome in. How you doing? So we're live streaming on Twitch and YouTube. The majority of the notifications you'll see on stream will be from Twitch, but at present I have only subscribers notifications on YouTube. The only other notification is if someone drops a donation via Ko-Fi or Coffee, depending on how you want to choose to pronounce that. But yeah, they're the alerts that you'll be seeing on stream. Right, okay, so we need to populate this bearing, and I'm just looking at the, there we go. I am just looking at this bearing to see where the screws are populated. So they're the first hole, and then they're odds. So what I like about this model, is there any brand that's better than others? Probably. I've literally bought the cheapest one I could find on AliExpress. This is an incredibly tight build budget. You could probably get Limu bearings. Is it Lima bearings? They're like a manufacturer of stepper drivers, and I believe they do linear actuators and linear bearings and all that sort of stuff, but they're a bit pricey. So yeah, it's a bit of a, for me, this is a means to an end. I don't know how they're going to perform long term. They could be absolutely rubbish, or they could be adequate. It's not like there's a huge load of stress that is going through this system, right? It's not like I'm building a CNC machine here that is going to be doing milling. This CNC machine is picking up components which are, you know, 0805, very, 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 very small components. So it's not like there's a lot of weight that it's throwing around at speed. So we'll have to wait and see. Yeah, absolutely. Thank you, Buck. So yeah, if you want to hit that follow, if you're getting some value out of this stream, please hit the like button. I got to keep my terms separated from Twitch. So Twitch is follow, And on YouTube, it's subscribe. Those activities on each of those platforms are free. So all the support, just you hanging out here, is definitely appreciated. Yeah, it's about 2,000 US dollars about us. It's quite expensive. Right, okay, so let's find out what screws we need. Now, this is what I like about this model. I got to say, I can't stress this enough, that the documentation on this project is incredible in terms of the level of detail that is in here. It is absolutely crazy. Right, I'm having some chat issues on my screen. One moment, please. I'm gonna have to just keep. Now this is working perfectly before stream, and wouldn't you just know it? Anyway, we'll muddle on. Like 10,000 Canadian. Oh, what? Man. Hey, SWK, welcome in. Yeah, sorry, Slingshot. But I think Limu bearings, if I'm pronouncing that right. What is this? The PNP? Yes, it is. We're building the LumenPnP. So we're just looking at how we need to install these linear bearings. And we're going to get into that right now. So let's jump back to the overhead camera, and we need to install a series of T-nuts and screws. And with this documentation that we've got in the project, I can just come in here, I can select the screw, and it tells me, it highlights, it's an M3x8 screw. So let's get some hardware. Let's get some hardware out of the box. So first and foremost, we need T-nuts. All right, there's my T-nuts. And we need, what do we got? M3x8. All right, they're surely not M3s. I think they're M5s. Well, we're going to be using M5s. Uh-oh. Uh-oh. Have we got a problem? We might have a problem here. We may be running into an issue. Right, these are M5x10s. Okay, let's go in. Right, let's get all this hardware out of the box, and we can kind of evaluate where we're at. I think we might have a problem in that the hardware we've got may not fit. We may have miscalculated. Let's then by 16s. Right. If I can't pronounce it, I can't afford it, right? Okay, please pass through. Please do not pass through. Okay. So Houston, we have a problem. All right. So how are we going to overcome this issue? So first and foremost, I need to find out how many I need. So it's 2, 4, 6, 8, 10, 11. Right. Okay. So We've got 11 M3 nuts we need. Right, I'm going to go into my hardware box. So this is, we're going off piste here. We're going off script. So let's bring, I should have checked. And this is where this is going to bite me in the backside. So post that in Discord, SWK. I'll take a look at that shortly. Right, I'm going to have a look at what M3 hardware I actually have in my box of goodies here. And I'm going to be digging deep into Frank's pit of materials. Right, so I have these M3 bolts, etc., that I got from when I built Frank originally. So I'm hoping that will pass through this bearing. It will. The question is will this foul on the rail? Or will it... It's going to foul on the rail, isn't it? Yeah, I knew it. Yeah, it's going to foul on the rail. Nice. So we need a smaller... M3 bolt. We could be in real trouble here. Right, so we need something smaller than this. Okay, so that's the same size. Are they all the same size in here? They're looking like they are. Yeah, they're all the same size. We've got problems. So I need to identify some M3 hardware that we can use to install these bearings. And I'm just looking to see what, if any, M3 hardware that I've actually got in this. This is somewhat involved. This is somewhat bolt depot activate, right? Yes, I am scavenging parts from Frank SWK. The LumenPnP is Frank. Okay, so we do not have any M3 hardware that I can see. I've got one more place I can try and locate some M3 hardware that we might get us out of jail, but we're currently not looking good. I'm just looking in parts bins of yesteryear to see if I have stowed components or parts away, but I think I've migrated away from that, and that is a bust. That is a bust. Okay, nil point. Well, there are words that I would like to say right now, but I can't, if you know what I mean. Okie dokie. So that means I'm going to need to be on the hunt for some M3 hardware. This is a bit of a kick in the teeth. So, okay, what can we do? What can we do to keep the project moving forward? What we can do is to... Yeah, that's no good, is it? One tiny screw by itself. Blast. That's so irritating. Right, okay. Let's get the lid on before I knock this over. And that's where forward planning would have helped me, but I made an assumption that hardware was what I needed. I thought I'd gone through the bill of materials properly, but obviously I misread things somewhat. I mean, I don't even have the T-nuts that we require. Now I've got an old screw bin here, but it's just mixed screws, so I don't I'm gonna have to place an order for some parts. So let's move forward with what we can. Right, let's start building out the X-axis and get that built. So that's ready to go come time that we've got the right hardware. There's a few bits and pieces that we can do still, though. There is some parts that we can still work on. So what do I need? What do I need? I'm thinking out loud. I require okay, let's build the X-axis. I need, that's it, the pulley. I need the pulley. And I need some hardware for that. So let's have a quick look at what hardware we need. So this rotation system, this orbital system that we got in FreeCAD is kind of messing with my head. Okay, so we've got our pulley. We need, what is that? An M525 screw. M5 by 25. Yep, there's the M5 by 25. So all of these components about us have been purchased individually. There is no the error is mine and mine alone. Okay, so all sorts of gremlins are in the machine tonight. Things are conspiring against me, but we will persevere because that's what we do. That's what we do. Okay, let's power down my extreme controller because Cheap Deck is on the fritz tonight for some reason, and it's been working. Everything has been working, everything, and then all of a sudden, the moment you hit that go live button, it all goes sideways. Improvise, overcome, and adapt is the mantra, right? So we keep moving. So I've got a nut. There's a nut that's inserted here, and we simply just tighten that up. We don't want to pinch the bearing. Okay, we've got some material in the hole, which we just need to poke out. Just use some tweezers to get that out. A little bit of support material from when I printed this. Now, had I been able to find the T-nuts, sorry, not T-nuts, the M3 hardware, I still don't have the T-nuts. So what I would have had to have done is to 3D print them. So should submit a ticket to the Cheap Deck devs. Yeah, I think they're on stop tonight. I think they're on strike. What is it tonight about things? I just don't get it, man. It's anyway. I guess this is what defines us, right? If we give up after the first sort of, you know, bit of resistance, then the victory of overcoming these problems doesn't taste as sweet in my view. But Maybe I'm just a bit weird like that. Okay, just digging out support material. If any of you have removed PETG support material before, it can sometimes be a little bit of a pain because PETG loves to stick to itself. I mean, like, it loves to stick to itself with a passion. So, get rid of the waste. All right. So next we need to attach this to this bracket, and that's going to allow us to tension the belt when we get to the point where we can install it. So what hardware do we require for that? So if I select this bolt, we need an M5 by 40. So let's go through my parts and find an M5 by 40. M by 16, M5 by 40. See, I placed a batch order for all these bits of hardware, but clearly I didn't read the memo that said I needed M3. I feel quite the doofus right now, but it is what it is. We keep moving. All right. So all of these parts have been 3D printed, with the exception of this 2020 rail. I don't want that to be as tight as it is, so let's just back that off. Just double check, what screw did I use for this? Oh. Did I use the same there? I did. I used a locking. I've used the wrong nuts. Thanks, Vex. I appreciate that vote of confidence. Okay, I have used the wrong nuts. I just need to switch them out. I've used standard nuts when I should be using nylock nuts so that these things don't come undone. So let's swap these out. Should be relatively straightforward to swap these out. All right. I can say it's all going wrong tonight. Netkisser, welcome in. That's the thing about upgrading. You end up... It's a little bit like decorating. You do one room, and then the next thing that you know, that the rest of the house looks like horrible. So you go on to the next room and you decorate that, and on to the next room and you decorate that. And by the time you get to the end, the first room that you decorated looks hideous and you've got to start all over again. So, the joys of being in tech, right? All right, okay, so, and it's not that part, it's this part. Okay, so we want the screw facing there. Put the bolt through here. We'll grab another nylock inserted nut. And then we'll just tighten this up and we can move forward. It's over 10 years old. It's crazy, right? Because I looked at the order form for the current machine I'm streaming from, and it's nearly 8 years old. I normally have a rule. I try and buy the best equipment that I can at the time, with the intention of trying to make it last for about 10 years. So I'm going to have to start a savings fund to build my next PC. That's going to be an interesting proposition. Right, okay, so now what I'm going to do is we're going to install this section onto this rail. And we need, let's have a look. We need an M5 by 10. M5 by 10, where are you? Is this an M5 by 10? M5 by 10, right? And we need these nylon, we need these T-slots, T-slot nuts. So we need 2 of those. I need to recall how you install these because I'm stupid. You got an RTX 4060. Nice. I bet that wasn't cheap. Okay. I see which way these go. Right. So let us get our M5 by 10. Now this is going to be interesting. I'm not quite sure how I want to try and install these. So I'm gonna try an experiment. I'm going to place the part on the end of the rail. Like so. Come on. Behave. There we go. And then I'm going to place the T-nut in the slot. And I need to orientate it so it's facing the right way. And that's the wrong way. There we go. And it's in the slot. So now, what I'm going to attempt to do is slide this down and get it to roughly where my tweezers are. If I just tip it up, can I slide it into place? I can. Good. Now I just need to persuade it to go a little bit further. Can I grab it with my tweezers? Come on. Was there a notification that I just missed? I heard a sound that sounded like a notification. Okay, and now I've got that roughly in the right spot. I think I can drop this down inside here. And then tighten it. Will it grab? Oh, winner, winner, chicken dinner. Cost you 300 euros. Ouch. Ouch. So I'm hoping to build this LumenPnP for approximately that much. Between 300 and 500. The unit to buy is going to be is 2,000 US dollars. So that's crazy. Okay. So that's one side on. That's pretty cool. Now, do I install the motor on here? Yeah, let's install the motor on here before we put it into service. So let me grab my motor. I'm going to remove the pulley. So this is one of Frank's motors. So we're using Frank's NEMA 17s. We're using Frank's, let me think, what else we're using in Frank's? We're using his GT2 belts. We are also using his power supply. A lot of the hardware that we need for, let me think, for wiring. So like the power harness, we'll be using that. So there's quite a reasonable amount of Frank in this LumenPnP to the point where I'm comfortable and happy to call this LumenPnP Frank. Right? It is Frank. Let me see if these M3... I'm using Frank's M3 screws. Yeah, we're good on that front. Okay, just need to double check I'm installing this motor the right way. So let's have a look on here. So the motor is facing down from above. So let us do that. Down from above. Now, where does the cable management go? Okay, so it's like that. Yeah, like that. And the cable needs to go this way. Yeah. So it needs to be this way. So what I'm going to do is I'm going to get this screw started. But I'm not going to fully tighten it. Like so. In fact, I'm going to just make sure I've got enough on here to... Okay, so that's just locked up. So I either need to find some way of spacing that out with washers maybe, or I need to find another screw which is shorter. That's irritating. All right. What have I got that's shorter than these? And I need 4 of them. Oh, God. Yay. No, one of you. I got 2 of you. Are you the same size? You are indeed. You beauty. Right, I've got 3. But it's not the right number. 3 is the magic number. No more, no less. Okay. We shall pop these away. And I am what appears to be short. Just checking to see if I've got any other hardware that I could potentially use. I've got a brass. That's the one. No, that's not gonna work. That isn't definitely gonna work. So I think what I might do is if I grab some washers, I might be able to take one of these slightly longer screws, stack a few washers, and make a spacer to accommodate for the fact that I don't have the correct length hardware. I'm waiting for the comments. Okay. So let's drop that in here. Let's just nip this one up nice and tight, and we'll just make sure. Okay, so we've got purchase on that, so that's good. So I'm going to do 3 corners. I've slackened that one off so I've got some movement in this, because the holes may not perfectly line up with the... It may not line up perfectly with the holes of the motor. So in doing this, I've got a little bit of wiggle room. Oh, that's going to be somewhat challenging to install. I've just spotted a component that I think needs to be installed prior to the motor going in. And it's going to be an absolute pain to try and install it if I don't do it now. So I'm just going to quickly check on chat. So there is a bracket that needs to go on here, and there are inserted nuts just in there. So they are going to be an absolute nightmare to try and get to. So let's find out what hardware I need for that, and then we can kind of install it from there. Okay, what is that? That's a M5 by 16. So let's find my M5 by 16s. Okay. And do you know what? I think I'm going to install a locking nut here. No, they're captured. They're captured, so I should be okay. I should be okay. Let's get... Gotta look at this to see. So, have you got any monitors in mind? See if I can get a view inside here. Right, let's turn this motor off for a second. Can we see? Oh, where did it go? Where did you go? Okay, so yeah, they're regular bolts, regular nuts rather. Okay, bring that NEMA 17 back into play. Yeah, I think so. I got an ultra wide as myself. I think height wise, it's vertical height that is the issue with mine. I should have gone for one that was taller, but you know, it is what it is. Right, let's get the bolt in here, and I'm just gonna put these nuts into their place, or at least attempt to, and then I'm going to use the hardware. Okay, so what I'm finding is there's possibly a bit of elephant's foot on these holes. There's possibly some elephant's foot going on these holes. Elephant's foot is where the first layer squishes and it spreads like an elephant's foot. You know, imagine all that weight coming down on an elephant's foot, and at the bottom you get that bulge. That's what elephant's foot is. So we possibly got some elephant's foot going on here, meaning that my M5 hardware will not fit in this hole. Oof. Go big or go home, right? See where you're going with that. I mean, I hope so. I'm gonna use a round file just to open the hole up, and I'm gonna do that over a bin, so that it's not going over my floors. But unfortunately for you guys, you can't see it because I am now currently off camera. But we'll work the problem. Okay. Getting there, almost there. You can, depending on your slicer, you can compensate for elephant's foot. If you know how much you're getting, if you can measure it, you can actually put a compensation in the slicer so that it actually shrinks layer 1 by a set amount, so that when it prints down, the elephant's foot expands to a position where you get the correct layer height. So it's pretty clever that they put that. Certainly Prusa slicer, which is the slicer of choice for me, it's pretty clever that they put that in place. I do like that. Okay, almost there. I've got one hole now fitting. Very close to getting a second. And I mean, for anybody who thinks that you just buy a 3D printer, press a button, and your parts just pop out and they're perfect and there's no failures and, you know, there's no cleanup work, there's no, you know, it's just done. I'm sorry, the days of the Star Trek replicator are not quite with us, and you do need to do some cleanup work. There is stuff to do. CAD vision! Or a flat foot. I just yeeted a nut into oblivion. Okay, so I'm struggling to actually insert these nuts into position. I'm not quite sure what the deal is here, but we do need to figure something out. I think what I'm going to try and do is, and this could be a horrible idea, right? This could go horribly wrong. What I'm going to do is I'm going to thread the nut onto the bolt, and then I'm going to tighten the bolt, and I'm going to drag the nut into its position. Now, that is what is supposed to happen, but if the tolerances are too close, then there's a chance that I could actually just split the 3D print into pieces. So here's hoping that does not happen here. Okay, the nut does appear to be going into its position, which is marvelous news. Okay, we can back that off. Okay, so that's part 1 complete. We need to do the same on the opposing side to this little hole. So you can see now that that nut is in there. We got to do the same over here. So let's put the bolt in first. So now I've got to try and catch a thread, not cross thread it. Here we go. And get the Allen wrench onto the bolt. And then we can just tighten and drag the nut into its final resting place. And hopefully it doesn't split the 3D print. Just looks like on this part of the model, the tolerances are pretty tight, which is absolutely fine. It's a little bit of a fiddle, but worse things have happened at sea. Right, so we now have 2 regular nuts inserted into our 3D model. And like I say, if you haven't checked out the LumenPnP project, go ahead and check out the link in the description of the YouTube video. There is a link to Opulo where you can actually buy this machine completely partly assembled. Going to say completely assembled then, but that's not true. You still have to put parts of it together. These holes need to be widened. Let's bring this crash bin in front of me so I can just file and get this hole sorted. Like I say, a little bit of finagling, a little bit of finessing, and we can get this to fit. So we were looking at getting the motion system in place tonight, But unfortunately, I have had an oversight in that I do not have the correct hardware to install the linear bearings. I need M3 bolts. And now there's a full bill of materials. I'm going to go back and check the bill of materials for the project, and I'm going to see whether or not there is M3 bolts in there and I've just completely missed it, or whether or not the bill of materials is incomplete. So we're playing this game on hard mode, right? So we got to expect things like this. And when I say we're playing it on hard mode, what do I mean? We are building this machine totally from scratch, and that includes the motherboard. One of the things that I need to do is to get the plans for the motherboard sent off to be manufactured. And then I need to get it populated with the components and soldered. So I'm toying with a couple of ideas here. One idea is that I hand solder everything. The other option is that I test out a board manufacturing company to see whether or not, what the experience is for fully assembled boards. Can you imagine trying to install this if I had that NEMA 17 in place? That would be nigh on impossible. Hey, keep dropping it, Steve. That's just the way you are. Right, so that goes there. So that then must bolt in this side. Let's put it like so. So yeah, I'm tempted. It should be called a parent board. Yeah, there's a lot of terms in IT which generally get frowned upon, right? I'm not going to go into those here, but these are industry standard words that some people may not like. 16, so I need another one of those. Pop that through this hole. We can start tightening this. Then we can get and look at trying to install we can look at trying getting to install the there we go. My broadcast software just had a moment there. So yeah, trying to install this bracket with the NEMA 17 in place would probably nigh on impossible. Now it does pose a logistical problem of how do we install the motor now? We've got this leg sticking off. So I think what I'm going to do is I'm going to just take this arm and put it over to one side, and I'm going to hang this over the bench, right? These wires will go through this opening here. And I've got to build the wiring harness and everything, right? But yeah, I've got... I don't like doing things easy, right? I always seem to find the hardest way of doing the simplest of things. And I need to reevaluate. I need to reevaluate that stance. Because that isn't the most savvy way of going about things. The only thing I will say to that is that it does playing these games on hard mode gives you a level of experience that you can't really. Well, can you buy that level of experience? I don't think you can. If I'm being honest, you can go to school, right, and have a tutor that will help you get a result. So the tutor will take you from A to Z, and you follow the process. And every time you do that process, you go A to Z. And I think doing so to some extent is you're doing yourself a bit of a disservice in that there is a journey that you go on as a maker that is muddling through things, doing lots of things wrong, to then finally hit upon the right way of doing something. You mean learn way more doing it the hard way? Yeah, I think so, right? It's that whole adage of sink or swim. And, you know, I think that's probably a bit too much in the way of a spacer. What I'm doing here is I'm putting some M3 washers on the base of my screw to kind of like stack it out and hopefully give me enough material to be able to screw this into the motor. The question is whether or not that'll go down inside the hole, and it will with a bit of persuasion. But yeah, you do learn a lot more the hard way, in my personal opinion. I must admit, I've always played the game on hard mode as a maker. That may not suit everybody's palate. It depends on what your objective is. And I've said a number of times, there's certain things that I do that, you know, I could do in a different way, still get the same result, but with less stress, less effort, less time. But it's, what do you value? What is the value proposition that you're bringing, right? And the value proposition I'm seeking is the knowledge. I'm seeking skill. Now it looks like that might be too much, because that screw is now not making it all the way through to the motor. No, it is not. So I need to bring some of these, somehow bring some of these washers out, which I've just rammed down inside the hole. Okay, there's one. Okay, there's one. There's two. Let's see if that'll do it. Okay, I've now got one that's decided to go sideways. I mean, literally sideways in the hole. I wish I could show you this, but do I try and dig that out? Do I try and dig that out? Yeah, I think I'm going to try and dig that out. Don't particularly want to take this mount off this motor again. So I'm trying to dig out. There's a little ridge on this Allen wrench. Come on. There you go. Okay, that's just sat down. Where that should allow the bolt to pass through. It does. Good. Whew. Let's just hope there's enough on it now. Measurements, cut twice. Buy a new piece. What are you trying to say, Buck? I can't repeat what you're saying on YouTube. But I get your sentiment. I get your sentiment. But no, I value the learning. And it's, you know, there are some really valuable lessons in the struggle. So, as you've noticed, those of you who have followed me over on Twitch for any length of time, you know that, you know, I'm in a hyper budget sort of situation. The key thing for me is that this hyper budget situation is quite stressful, because it means I can't, you know, put the resources into a particular project that I would like to. But that forces me to be creative. I have to do more with less. So that is ultimately where I'm at the moment, is that I'm trying to do more with less, which is why I am building a LumenPnP machine as opposed to buying one. I have, so for context, I have a project that's going to require me to manufacture some circuit boards. Probably, well, we're probably looking at about 50 boards that need to be made. And for the vast majority of these boards, they're going to be made by hand. And the reason for that is that the LumenPnP is not going to be ready in time for us to use that in a production sense, unless it's towards the end of the initial run. That being said, the machine will definitely get used on subsequent batches. So, you know, this is going to be put into good use. And I'm intending on offering circuit boards on my website for projects that I'm building. So, for example, in the last live stream, we were working on a 4-channel 12-volt or low voltage IoT device that could incorporate into Home Assistant and the like. The thing for me is that I'm gonna make that available so people can make use of it. Possibly even make some different modules as well. Make ones that are like maybe 1 or 2 channels. Because who needs a 4-channel, right? I do, but does everybody? Right, let's have a look at the hardware that we need here again. So we are looking at an M5x10 screw. What is the difference between a screw and a bolt? I've been calling them bolts, which is probably triggering the engineering people amongst you, right? How many feeders will it have? So the machine, I believe, is capable of up to 50 feeders. 25 on the front, 25 on the back, and there's probably more that you can have on the staging plate itself. The threads. Buck, that's what I thought, right? I always considered anything with a machine thread that it is a bolt. And if it's got a coarse thread, it would be considered a screw. But I'm seeing conflicting terminology. All right, let's bring in our X rail. So this is our X-axis that we're building out, and we need to install the motor assembly to it. And that goes in this way, like so. Right. So what we're going to do now is we're going to attempt to install this the same way that we did on the other side for the pulley. We're going to drop the T-nut into place. We're going to shove it into position and then get the bolt from above. Online, a bolt is meant to be used with a nut and is tightened by torquing the nut. A screw is designed to be used in either a pre-formed threaded hole, or it is capable of forming its own threaded hole. A screw is designed to be tightened by torquing the head. Okay, so what if I've got an M5 bolt, right? If I've got an M5 bolt and I put it into an M5 nut, we would say it's a bolt. But if I drilled a hole in a piece of plate material and tapped an M5 thread, does that make it a screw? Does that mean that the same thing can be both a screw and a bolt? Based upon the definition that Buck has posted into chat. That's a really kind of, that's getting into the quantum. That's getting into the quantum, right? Where you can have like quantum computing, you can have qubits that essentially are a 1 and a 0 at the same time. A bolt is a non-tapered fastener that is uses a washer and a nut to hold objects together. A screw is a tapered fastener that mates with an existing thread or creates its own thread in material that it turns. Non-tapered. So if it's non-tapered, it's a bolt, and that's regardless of its head. That could be an Allen bolt, like a hex nut on the top. It could be, oh, that's magnetized and it's dragging the nut back out. There we go. This is way easier. This is way easier than what I was doing before. I learned something. Who'd have thunk it? You can have a hex cap, like, or an Allen key cap, or a hex bolt, you know, hex top. It doesn't matter. Right, so that is my X gantry complete. Right, what else can we do? What else can we do? Because we're kind of at an impasse now because of the fact that the threaded, the nuts and the bolts for the bearings are not in stock. We don't have them. Gone. I think what we're going to do, I think we're going to let's install the feet, the risers. Why not? Because ultimately they need to go on at some point. So let's do that instead, shall we? Now there's going to be a bit of a delay on the video as we switch over. But let's flip over the frame and let's get these feet installed. Let me see, what do we need? What do we need? So we got a nut in the top and an M5 screw. See, it's called a screw here. M5 by 16. So let's go ahead and get those installed, shall we? Yes, 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 yes. So we've got a single. Let me get the feet. Where's the feet? Where are the feet? Okay, so that goes like that. Okay, so I think I'm going to have to do the party trick that I did before, right? In that, put the bolt in. I've been calling it a bolt all night, and I just going to call it as it is, right? I'm going to call it a bolt from here on in. I need a means to get the nut in position and actually catching. So let me grab a pair of pliers. I've got some long nose pliers here, and we're going to insert this. And this was always going to be a bit of a longer project, but I was hoping to be a little bit further on than we are tonight, sadly. But that's life, right? Sometimes things just don't go your way, and you have to overcome. Reevaluate your timescales. Okay, that is now in place, so I can undo this. The bolt is pressed into here. I do need to get some feet, some rubber feet, but for now, we can probably get away without them. Yeah, I can just reach. So this is the first of 4 feet going on. I need to buy some little rubber sticky feet. You're learning to be confused. About us, ask away, buddy. What do you want to know? This is why I stream. This is why I make videos. How can I help? So, what are you being sarcastic or genuinely? Do you want me to explain something? Because I am more than happy to go into that. Okay, I've cross-threaded the bolt, so I need to reset and go again. A little from column A, a little from column B. Okay. I'm still a little confused, but okay. If you ask a question, I will answer. If you ask it, I will answer. It's going to turn into an Ask Me Anything section. I can feel it coming. I can feel it coming. Okay. So that's the 2 feet on. So these feet are risers, and this just gives some clearance underneath the machine, so that the motherboard, etc., has just got enough room. I'm guessing airflow is a possible consideration as well. All right, so we've got 2 nuts per side this time on the front. Let's just break out some hardware. And let me just double check that we are using the same bolts versus screws versus machine screws. Then I ordered from Wish and all the descriptions change. About us, I gotta be fair, for a 3D printed sort of setup, this machine is brilliant. So Stephen Hawes, I think his name is the main founder of Opulo. He's got a YouTube channel. Check out Stephen Hawes. He's got a bunch of videos all about the Opulo, all about his workshop, all about the company that the open source company that he has founded, that one, makes these machines available for the community, and 2, sells these machines in kit form, and is actively developing, feeders and cool bits and pieces that go with this. I'm really impressed. I am really impressed with this machine so far, not just in terms of like the potential that this machine has in its use case, but also in is these holes loose? These are going to be loose, right? Oh no. But also in terms of the documentation. I have seen corporate projects with less documentation than the LumenPnP. I'm blown away. And the fact that he's made this open source for the community to use, he could quite easily have made this closed source and just sold an absolutely outstanding piece of hardware. But instead, he chose the path of open source, which is not an easy path. It is so not an easy path to go open source. And kudos to him and the team that he heads up. I think, credit where credit's due. I'm wishing them every success, and hopefully people who don't want to build a Lumen but want the capability of a Lumen see this stream and actually buy a machine You know, maybe Steven's watching at some point, and we'll have a coupon code, right? We'll get an affiliate link. Oh my word! What happened there? Who changed my scenes? It was not I, because you can see me sat here. That is my to-do list on my open source project. Go back here. Where did you go? There are ghosts in the machine tonight, let me tell you. That's super freaky weird. I know, right? You guys see me working. I didn't press nothing. I didn't do that. Right, so that's leg number 1 at the front. Let's do leg number 2 at the front, and then that concludes the installation of the legs. So what's next? I think we need to start thinking about the electronics of the system. Once I got the hardware and the belts and all of the sort of axes wired in, what we can start looking at is the motherboard. I probably need to get the motherboard ordered. I'm also going to need to decide if I'm going to hand solder it, or whether or not I'm going to have an assembly made for me. But the big thing around doing something like that is is as it always is cost, right? So we'll have to do the math on the on having it built and whether or not it's feasible / affordable. Remember, this is a zero budget stream. Right, where's my box of bits? Here's my box of bits. Where's my leg? I'm missing my leg. I'll put it down here. Okay. So, we got any questions in chat? No, we do not. So, yeah, ask some questions. So, the LumenPnP. Let's talk about the LumenPnP. So, the LumenPnP uses OpenPnP as its control system. Essentially, what it does, it's an XYZ sort of Cartesian system. And if I'm not mistaken, the LumenPnP uses a forked version of Marlin firmware, which is more commonly seen in 3D printers for controlling the stepper motors, the pumps, and all of that sort of good stuff. What this system has going for it is that we install 2 cameras, one camera looking up, one camera looking down, and the camera looking up is used when we pick up a component. The Lumen will bring it over to the camera facing up, and it will figure out which way round the component is. And it will then rotate that component so that when it goes to its landing site, it's in the correct orientation. The camera looking down looks for the fiducials on the, and I didn't swear, the fiducials on the board. And the fiducials are like landmarks that the pick and place machine spots and figures out where the machine is in 3D space. So that's ultimately what the fiducials do. The cameras get plugged into a host PC running OpenPnP, and it's OpenPnP that does the vision. side of things to make everything work. It's the secret sauce that pulls everything together. It's that the sprinkles. Right. Okay. So we now have a fully assembled base. Okay. So this base is fully assembled. This essentially is going to drop on top like so. Right. You can see it's starting to come together now. There's a stage that goes in here, and we're going to go with, I think it's 3 or 4 stages that we're going to put in here to maximize the amount of space that we have available for board manufacture. So what will happen is the boards will come in either as a single board, or they'll come in as a panel. A panel essentially, in fact, I think I've got something that resembles a panel here. Yeah, let me show you this. So this would be considered a panel. It's a series of circuit boards that can be broken apart. So imagine this repeating, this whole arrangement being repeating, and you maybe have like 4, 6, 8 in a panel, and you load the panel up, and then you get it so it knows where all the fiducials are on all of the boards, and then you run a job where it will put the components onto the boards. Now you still have to put the paste on the boards. So what you do is you get a stencil. A stencil is a thin piece of metal that has holes cut in it that represent where your component pads go. And essentially, you place this stencil over the board. You get solder paste, which is solder balls held in like a paste in a flux paste foam, and then you scoop, like screen printing, over the top of your circuit to lay down the perfect amount of paste. Your components get dropped into that, and then the board goes into an oven and is heated along a specific profile for your solder paste that enables it to then fully solder. So when that gets taken out of the oven, all of those components are now soldered. How many panels is the minimum order from PCB places? So panels are not the same as individual boards. If you want to go to a manufacturer to have boards, PCBs made, like for example this one. This has been professionally made, and there's a minimum of 5 circuit boards that you have to order. If, however, you want a panel, that's something different, right? So you're asking for batches. So you might ask for 40 boards, and you might have those broken into panels of 6, right? Or whatever's divisible by 40, for example, right? You get the idea. And then all you do is when your panel comes, there are what are called mouse bites. Let's see if I can get up close to show you the mouse bites. Can you see that? The lighting's just not quite right. Yeah, you can see it just in this corner here. Just there. Right, there's a series of little tiny holes. There's like a perforated edge that you can actually snap the board off, and then you've now got a completed board. It's pretty cool. It's pretty cool. Right. So where was I going with that? Brain has ceased to function for a moment. I'm pretty annoyed with myself that I didn't get the right. I've not got the right hardware for the rail installation. So, given how detailed the documents are, it's probably me that I've missed it. In fact, let me bring up the bill of materials, and we'll see what I've done wrong. What did I do wrong, Governor? Okie dokie, let's see what we've got here. go to my drive. Go check. I've got a couple of BOM files. BOM, bill of materials. So if you hear the phrase BOM, B-O-M, stands for bill of materials, and essentially it's an itinerary of all the components that you require for a given project. That's a template, so it's not going to be that. Is it in here in this untitled spreadsheet? I bet you it's going to be in here, isn't it? No, that's not it. What on earth have I done with the bill of materials? I've been a complete and utter doofus, haven't I? Lumen, bare minimum. There we go. I found it. I done found it. All right. So let's have a look. What do we got? So all of these green components, these are all FDM 3D printed items. We've got M5 T-slot, M3 cap nut, M3 hex nut, M3 square nut. So M3, and there's M3 hardware in here, which you'll notice is not highlighted. Maybe I assumed that I would have sufficient amounts of M3 hardware from Frank and misjudged that significantly. That's a bit of a moment. So I'm going to have to go and figure what I'm going to do here for that. I'm going to have to, after stream, or probably tomorrow now, place an order for some M3 hardware, and at which point I can install the linear rail. So let me just talk quickly about the linear rail that I cut. So unfortunately in the design, and this would be a bit of feedback that I would give Opulo, in that the rails typically come they typically come in lengths of like 550, 500, and the rail for the X-axis is 525. So what I had to do, there's like, remember I said at the beginning of the stream, these bearings, if they come off, they spill all of these little bearings everywhere, and it's an absolute nightmare to get that like back in play. So what they do, they ship with these little bungs in the mounting holes, and what I've done is I've removed the bung from the very end, and I've placed it here, so that this bearing has very little movement along here. Can I demonstrate? Can I demonstrate the bits going flying? No. No, I'm not going to do that. Let me see if I can get you a close shot. Right, here we go. Can you see those bearings in there? I mean, you might be being facetious. You may not be. I don't know. I'm going to assume that you're not. Come on, camera. You got one job, and that's to focus. Why is it cameras don't like to focus? There we go. So you can see those bearings in there. And if this comes off the edge of this rail, what happens is all of the bearings have got like a little channel inside here. So as it goes up and down this rail, they'll slide, and they recycle, and they come back round. It's like a little racetrack inside here that recycles all of those little ball bearings. So if that becomes disconnected from here, those ball bearings go flying to the point that they actually ship. And I'm not entirely sure if this is a tool to load. So they send it out with this little plastic clip. right? And some additional ball bearings, like that amount of ball bearings is really going to make a difference, right? If this comes flying off. I think what this is intended for is that you butt this up to your rail and then you slide onto there, and you can see if that's the right length. Yeah, you could probably slide this onto. Sorry, you could slide this carriage onto this and keep all of the ball bearings from going like crazy. Yes, these are linear bearings. Yeah, you often find that like industrial machines will use this type of bearing system because they're more reliable, it's more rigid, it adds rigidity to the frame that it's sitting on. You know, it's an all-round better option. And if you look at upgrades for 3D printers, very often they will replace the V wheels, which essentially they're rubber wheels that are clamped tightly on a V-shaped extrusion, and over time that they wear down. These don't. If they're of an appropriate quality, the metal ball bearings in here won't degrade as anywhere near as fast as, it's not to say they won't degrade, but they won't degrade anywhere near as fast as V wheels. But yeah, a CNC machine, like for milling, is more than likely going to use something like this, or certainly a quality machine is likely to use something like this. My CNC doesn't. It uses LM type bearings, which is very similar in the concept of these bearings looping round. In fact, I got some LM bearings. I can show you LM bearings. Where's Frank LM bearings? Oh. Ooh, I've got 3D printed LM bearings. So this is a 3D printed LM bearing, right? LM8UU, I believe it is. Yeah, LM8UU. Just make that out. And essentially, in the ball bearing type of these, there is like little races again inside, and you're mounted onto a linear bar, as opposed to a round bar, as opposed to a profile bar like this. Logarithmic bearings are so much more fun. Is that the one where they like the ball bearings kind of like loop around almost like in a figure of 8 inside the casing? Okay, I'm just gonna test the YouTube chat a moment, because I know that that's not been the greatest. So if I'm looking, there's a lot of restream chat going on. Okay. Yeah, there you go. It works. It works. That's fine. Awesome. Okay, so what's next? So as I said, I got to get the motherboard ordered. So let's have a look at the motherboard a moment. Now this motherboard is pretty impressive. I gotta say. So there's two. Thanks to you, Waffle. There's two boards that I need to get made for this machine. One is the motherboard, and that is pretty heavyweight in terms of its design. So let's have a look at this board a moment. So here's the board. It's actually a 4-layer board. There is a lot going on in here. It'd be interesting to see how big this board is. So very often, board manufacturers have a maximum size that you can make, and typically that's somewhere in the region of 100 millimeters by 100 millimeters. And it'd be interesting to know what sort of size this board is. So let's use the measuring tool in KiCad to see how big this board is. So let's pop a little marker. Let's go for this corner here. Okay, you'll notice that my grid size is, I can't get on the line. So I'm just going to alter my grid, and I'm going to reduce, make it a little bit finer. No, it needs to go again. There we go. Oh, it's not getting in the center. There we go. Right, so let's find out what the dimensions are. What are we looking at? $99.99998. What's the bet in this board is effectively the maximum board size. Let's just do a vertical test. Let's go from here. Because that's kind of smart, right? That is pretty smart if that's exactly what they've done. It's 100 by 100. That's pretty clever. I'm impressed with that. Because when you go to order this now, it's the maximum size. So here's the thing, right? Let's have a conversation. So we talked earlier about my sort of incessant need to do things in a very complicated way. Now, point in question is I've got 2 options. In fact, I've got 3 options. One, I buy a motherboard from Opulo, and I believe the board is a couple of $100, right? Plus shipping. Or I can get the board manufactured. I already made the decision I'm going down the route of having the board manufactured. The question now becomes is whether or not I hand assemble it, or do I have it assembled? So let's, in order to get an idea of how much work we're talking here, let's take a look at the board itself. So if I jump into KiCad and I choose edit and view and then 3D viewer, what's going to happen is going to launch a 3D viewer of all of the circuits, the components, everything, right? You say have it assembled, save time and error. Yeah, but then I lose the bragging rights to say that I built this from scratch, right? To some extent. Do I? Nobody can truly say they did things without support, right? So let's remove the through-hole components. This is what we're looking at populating by hand. So all of these components, these resistors, these capacitors, and these ICs, these smaller ICs, including the large capacitors and the inductors. These are all components that I have hand soldered already myself, right? With a soldering iron. I think I'm definitely going to go down the route of flowing. So I won't be hand soldering these at all. What will happen is that I'll buy a stencil. The stencil will lay the paste down. The components get placed in the paste, and then it gets placed in an oven to be baked and have all the solder flow. And that's how these boards. That's how boards are manufactured at volume, right? So I'm not going to be here with a soldering iron, but I will need to hand place all of these components. The only package that I'm looking at on this board that I have some concerns around, because I've never worked with this package before, and that is this one. This is an STM32 microcontroller, and this is a resonator, an oscillating crystal for the clock inside this chip. It's to govern the number of cycles that the chip reads, right? So looking at the pitch of this, it's pretty small. I'd be interested to know what the pitch of this board, of this component is. I have soldered FPC or ribbon cable connectors at 0.5 millimeter pitch, and I did that with a soldering iron. That was fun. And if you mean fun as in torture, then yeah, that's what happened. So yeah, let's have a look at the STM32. Let's just double check. Let's just double check the component. Let's get the bill of materials for the motherboard. Okay, and boosh. Right, so we want an STM32. It's U1, I believe. There we go. STM. Okay. All right, I can already see what the package is on this. So, can I zoom? Is this going to let me zoom? Right, it's a QFP, LQPFP. This obviously means something in the world of the package that this STM32 has. It's a 14 by 14 millimeter processor, and the pins are 0.5 millimeters apart. So I already have soldered 0.5 millimeter connectors previously. So this would effectively be the same as soldering 4 FPC connectors facing away from each other, or facing inwards towards each other, whichever way you want to look at it, in one hit. That's a big deal, right? Because I've never done that quantity in one go. So what you're going to need to make sure, what I'm going to need to make sure is that pin 1 is over here, right, which is represented by this dot. And these pins here line up, these pins here. It's very easy to put the package down crooked. And if it's slightly crooked, like it could be perfect here on these 2 pins. But over here, they could be like right out because you've got like a 0.5 millimeter rotation in the component. That can be, I think Stephen Hawes actually said with the Lumen, package orientation with larger components can actually be harder than with 0402 components, which are teeny tiny. Right, like these capacitors are 0805, so 0402 is like half the size again. Imagine something a quarter of the size of that, and it's the Lumen's able to pick them up and place them properly. But this package here, if it's slightly rotated, it's not going to solder. It's not going to flow properly. So that's a challenge right there. Oh, so the big things for me is that if I am going to hand solder this, 1, I need the right flux. 2, I need the right paste, because I think spending the extra money on getting the right flux and the right paste is going to pay dividends when it comes time to putting this together, because otherwise I'm going to be fighting the materials that I'm trying to use to lay this down. And it's not going to be a case of competency at that point, right? You can fail because the materials that you're using are poor, not because you lack the skill to use them. So I would, over the years of doing things on the cheap, it's all well and good to experiment with cheap materials, but when you come to do it for the real, then it's worthwhile spending the money on having the proper materials to do the job. You will find that the job will be easier that way. So once all of this has gone through a flow oven and all of these components are down, we then have to do the through hole components. Let's get rid of the SMD components and leave all of the hand solder. This is stuff that's done with a soldering iron at home. If this was being manufactured in a factory, there would be a solder puddle. So you'd have a machine that melts the solder, and it's like a fountain. It kind of recirculates liquid molten solder, and then the board goes through, the underside of the board goes through that, and the exposed pads and the exposed pins like suck up, or the solder adheres to the copper and makes the connection, and these are all like soldered in one pass. A machine probably comes and puts all of these pin headers and sockets in place, but then the machine is like on a conveyor belt, and it just on the conveyor belt skims the bath of solder and makes the connections. But I don't have one of those, so I will be doing all of these components by hand should I go the route of having, me making this board myself. So can we have a vote in chat who would like to have a stream of me soldering these things, this board up? Let's do this ahead of time. Let's get a show of hands. Always what? So what's the question we're asking? We're asking the question of, should I live stream soldering this motherboard up? It's going to be a bit of a stream. 42, I like it. It's going to be a long stream because I'd like to do it in one take for the pasting of the board, the placing of the surface mount, the flowing of the surface mount components, and then finishing it off with hand soldering the sockets, and then programming the board. The board then has to be flashed with its firmware and tested to make sure that the computer can talk, it can talk to it over USB. So it's a big ask. Sounds great. 24-hour soldering stream. You know me so well. You know me so well. Okay, so everyone on Twitch seems to want to have a soldering stream. I'm going to put a poll up this week on YouTube to see whether or not you guys would want to see me do a stream for soldering. And let's do an official poll on YouTube to see how many people would want to see that. It is going to be a mammoth stream. I'll have to figure out how long it's going to take, and maybe I do it on a day off from work, right? A day off from the day job. Right then. I think it's about time to land the plane. So is there any questions that anybody has? Regardless of what platform you're on watching this, if you're watching the replay on YouTube, feel free to ask questions in the comments of the video and I will respond accordingly. But for those of you in live, have you got any questions for me? I'm going to see if I can do another live stream this week. If I can get the fasteners in time, I will see you waffles. That command only works, I believe, on Twitch. I need to unify the bot so that we've got one set of commands and it'll work whatever the platform. But equally, I don't want to cause an echo chamber where the chat that gets transcribed from Twitch to YouTube triggers the bot and it just like goes backwards and forwards, right? And therefore, Twitch is superior, says Vex. So, like I say, I'll do an official poll. Are there any questions before... I'm not reading that one. Are there any questions before we land the plane? So we're going to do something known as raiding. For those of you on YouTube, raiding is where you take your audience from your live stream and you take it over to somebody else. I see what you did there, Vex. We're gonna do a raid, and we're gonna see. We're gonna take the audience Twitch over to somebody else who's live streaming on Twitch. This is something which is considered a good thing, and it just helps promote the creators on the platform. So, thank you, Buck. Appreciate you, man. So, any recommendations for the raid?
78 is making it rain with 22 bits.
Aw, dude! Oh, guys, thank you so much. Appreciate the bits. I should have had 42 twice. That's hilarious. Right, okay. Let's look, the clock was going. Did you see the clock? That's awesome. Thanks, guys. Appreciate you. Right, okay, let's have a look at Twitch. Let's see who we can raid. There aren't any recommendations right now. Yeah, I probably need to bring the brightness. Let's see if I can do this. Alexa, turn main light on to 25%. How's that, man? You can see it now. Right. Who shall we raid? Any recommendations? Sorry, not sorry. We're not getting any recommendations in chat. You guys are too busy making fun. Right, let's take the party over to Orbiter Guitars. Orbiter Guitars is an awesome luthier here on Twitch in the makers and crafting section. And a luthier, for those of you who don't know, is somebody who makes stringed instruments. Orbiter makes his own guitar pickups. I believe he does his own builds. He is helping me, along with another luthier, to make a Fender style jazz bass. And this is something that I haven't promoted on stream for a while. I am making a Fender style jazz bass, and I'm also documenting this on YouTube. This is where our progress has got us to so far. This is a test of the this is a test of all of my CNC tool paths. I'm going to be remaking the neck, and I will be making a video on how I'm making this neck in the upcoming weeks / months ahead. There's a lot to be done at the moment on projects that have to unfortunately take priority, but we will get to it. So thank you, Abaddis. Appreciate that. Yeah, it's a long time coming. I'm making a pickup. I got a pickup winding machine that I'm building. So I want to get that finished. And we can start making the pickups because we're making the pickups for the bass. Like I said, I told you, I play things on hard mode. So let's go ahead and get this raid set off. We can start landing the plane. Would help if I pressed the right buttons, but you know. Alrighty, so here we go. Let's go for the raid. That's inbound now. I can't bring that up on stream. I don't think the YouTubes will like that. Okay, the raid is underway. Thank you so much for everybody that's hanging out. If you're watching on YouTube and you like the video, please give it a thumbs up. If you're not already subscribed, hit that subscribe button. If you're watching on Twitch, thank you so much, guys, for chatting and for just hanging out. Hit that follow button. Remember, follows are free on YouTube. On Twitch, and subscribes are free on YouTube. It's messing with my head, but no, I appreciate everybody. Until next time, have fun, be safe, and make something cool. Until next time, bye for now.